Okay, cyber attacks. I'm going to concentrate here not on state-sponsored cyber attacks. I'm going to, in keeping with this section, I'm going to concentrate on just non-state sponsored. So it could be terrorists, could be just really bad guys. Okay, so here's your bad guy. Okay, so here, these are a bunch of press releases. So these are titles taken from the press in the past year. Here's one: a prison computer gets hacked, releases inmates from their cells. This happened in 2013 in a maximum security wing of a prison in Florida. And initially they said, oh, it was a computer glitch that opened up all these cells simultaneously. But then later on they figured out that, oh yeah, this was after the $1.4 million security upgrade. But then later on they found out that, well, it looks like it was hacked, actually, by either the inmates or most likely accomplices of the inmates from the outside. Here's another one. This is the language of the press release. Probably all these should be in quotes. Creep hacks into a baby monitor, shouts disgusting words at sleeping child. What happened, this was last year, a Texas couple, they heard unfamiliar voice coming from their 2-year-old daughter's baby monitor. Turns out some bad guy managed to hack into the monitor from outside, and it included a camera, and began shouting horrible things at the sleeping baby. Luckily, she couldn't hear it because she was born deaf, and her hearing implants were turned off. Here's another one. A famous hacker discovered that hacking a pacemaker can kill someone. So it turns out pacemakers apparently can get hacked into. Who knew? And this is a guy named Barnaby Jack, and he figured this out, and he found he could hack somebody 30 feet away and kill somebody with a pacemaker. And he was going to demonstrate this, but ironically he died just a few days before he was supposed to demonstrate this at DEF CON. Our cars have gotten so smart they've become a target of hacking. Basically, our cars are now computers on wheels. And some guys figured out that it was really easy. There were virtually no safeguards in place on these computers. Okay, so anybody could hack into them. They did that on purpose so that when you drive your car to a gas station or a service station, they could just plug their monitor into your computer and get to work. You didn't have to supply them with a username and password, right? So when you're able to hack into the car, you can control all kinds of things, including the brakes, including the steering, including acceleration. I don't care about the lights and the horn, but you can do a lot of bad stuff. And this isn't theoretical. People demonstrated this. Okay, you're watching TV, but a hacker is watching you through your TV. How could that possibly be? Well, there's a lot of smart TVs out there that have built-in video so that you can, Skype with your friends over your TV. Well, people have shown that they could hack into these TVs and they could watch you watching TV. I don't know if they're doing that at my house. It's phenomenally dull, whatever they would see, but nevertheless, it's kind of creepy. So here are some potential targets for terrorist attacks. I doubt a terrorist is going to want to hack into someone's TV and watch them watching the Kardashians or something, but what can happen is if you can really hack into things, you can affect power grids, chemical plants. You can have a chemical plant essentially blow up if you can control it from the outside. And they can be hacked into. Power grid, the same thing. Right now, as we go, like smart cars, as we go to a smart grid for distributing energy, it's more vulnerable to really bad things happening by people that hack into it. The defense industry, I mean, good grief, you can hack into some company that works who has contracts with the US government. You could find out all kinds of weaknesses in different weapon systems or other intel. The banking system. If you hack into the banking system, you're thinking, okay, so a couple of banks are inconvenienced. No, if you shut down the banking system, you don't have any money. Right? We don't carry around big wads of cash anymore. We go to ATMs. Sorry, they don't work if the banking system's down. Okay, could I go to the bank and just write a check? Sorry, we can't verify that that check is any good. We can't hand you money because we can't open our vault because our banking system has been shut down. It can really be bad. People can starve. Okay, you try going to Dillon's and asking for food. Okay, and saying, well, the ATM's down. When it comes up, I'll be glad to pay you. No, it ain't going to work. Okay, this is really bad. Nuclear weapons facilities. You can just totally shut down their defense systems. It can be really, really nasty. So the addressing system, it's called Tier 1 ISPs, they're the backbone of the internet. In the US, we've got 6 of them: Verizon, AT&T, Qwest, Sprint, Level 3, and Global Crossing. What these things do is they convert word addresses into numbers. Like if I want to go to Google, I'd say www.google.com. Well, the computers don't understand that. It goes out to the ISP. The ISP says, oh, what you really want to do is go to this numerical address. So it's sort of the translator from words to numbers to words, okay? Bad guy can hack in there and totally scramble it, totally shut down the internet doing that. There's something called a BGP, and what it is it's sort of the postal worker decides, okay, so all the internet's divided up into packets. Okay, if I send something, it goes out in packets. And somebody has to route, somebody or something has to route these packets to make sure what goes where, what goes next, etc. And that thing that decides is the BGP. The BGP has no security mechanisms on it. Zero. It works on the principle of trust, not trust and verify. So it's a wide open vulnerability. Almost nothing on the web is encrypted. If something really good happened out of this NSA business with the so-called spying on the internet, and that is a lot more companies, a lot more people are encrypting what they send, because the bottom line is almost nothing is encrypted, and hackers can snoop on anything they want to. You can also intentionally propagate misinformation, malware, viruses. Of course, everyone knows about this, and bad guys can do that and totally shut systems down. The internet is decentralized, and it was created by what the textbook calls now aging hippies, who didn't trust centralized control. It was exchanged for ideas. The internet, well, the World Wide Web was actually created by CERNs. Physicists actually created this, and they created it so they could share information. They're not interested in hiding stuff. They want to put something out there for everyone to see. Privacy was not an issue for the people who designed the web. And that's what we still have going on. And a quote from an expert on the field: everybody trusted everybody on the network, but like the tribal areas of Pakistan, not under the control of anyone, and therefore a place to which the lawless will gravitate. So this is something we, I think, definitely need to worry about. Now, dealing with terrorism is really tricky in general, all kinds of terrorism. If there are no attacks, people get tired of spending lots of money, they get tired of the hassles, and they get tired of the loss of privacy. Okay? If there are attacks and they're successful, people die. So what do? One thing we do is we try to develop technology to fight these things. But in fact, in many cases, it's our very technology that makes us vulnerable. For example, hacking, okay? Smart grids, etc. It's our very technology that makes us more vulnerable. But we can try to develop technology to make the bad guy's job more difficult as well. But that takes money too. So it's not just throwing money at TSA, it's not just throwing money at, computer experts to try to harden systems against hacking. It's also huge amounts of inconvenience. And if we're successful, guess what? People say, why are we spending all this money? If we're not successful, people die. So where do you put your money? Finite resources, right? Do you put your money to try to defeat big nukes? Bio, we haven't talked about bio, we'll talk about bio next time. Planes, to protect planes better. What about trains? For crying out loud, our trains are practically unprotected in the US and in most places. Office buildings, you mentioned Oklahoma City. Where do you put your money? You have finite resources to invest. If you don't put your money in, people will die. You put your money in and you're successful, people will say, why are we wasting our money? It's really, really difficult. This is where policy comes in. Science can help by trying to develop new methodologies, new ways of detecting explosives, for example, but it comes down to policy, really tough policy decisions. You got to know the science, you got to know what science can do, know what science can't do, but ultimately it comes down to policy and to a large extent comes down to money. And that's the facts of life.